Okay, so problem number 2 says to simplify the expression and to write the complex number in standard form. So if you guys have a division problem like this, what do we need to do? The conjugate, yep. So we're going to multiply the top and bottom by what? 4 minus 5i. Okay, so there was one like this on your final yesterday. The one on your final was just slightly easier because the top didn't have 2 terms multiplied by 2 terms. It was just 1 by 2, so you could just distribute. Here, since we are multiplying straight across, I'm going to use 2 rectangles to do my multiplication, one for the numerator and one for the denominator. But you guys could just distribute if that's what you're more comfortable with. So we're going to do I minus 2 times 4 minus 5i. The biggest difference is, I didn't leave myself enough room, sorry. The biggest difference on this problem is they put the I term first, so you might end up with things in a different spot than when you're used to seeing them, but it's still just all multiplication. So what is 4 times I? 4i. And then 4 times negative 2 is negative 8. And then for your bottom row, normally this box here is your I squared, but this time it's actually this one, because you're going to take negative 5 times I, and you get negative 5i squared, which would become just positive 5. And then negative 5i times negative 2 is 10i. Okay? So when you guys go to combine like terms for your numerator, you've got negative 8 plus 5 is negative 3 plus 14i, right? Okay, so there's our numerator. And then for the denominator, we have 4 plus 5i and 4 minus 5i. So this is the one where our I terms should cancel each other out. So if we take 4 times 4, we have 16. 4 times 5i is 20i. 4 times negative 5i is negative 20i. So those two will cancel out. And then if you have negative 5 times 5, you have negative 25i squared, which becomes positive 25. So 16 plus 25 is 41. And that answer right there is completed. The only thing is if all 3 numbers had a common factor, you'd have to reduce it, right? But we don't have to here. Now, a lot of times, because they say to write it in standard form, they want you to separate it. I did not count off if people do not separate this, because for it to be in standard form, you're supposed to have a real part separate from the complex part. So all they do is they write them as 2 separate fractions. But I don't really care because these two essentially mean the same thing. So I don't take off for it if you guys don't separate it. I'm completely fine with you leaving it all written together as 1 fraction, as long as you double check and make sure that nothing reduces. Okay? If you don't reduce, you would definitely lose a point for not doing the reducing. But that right there should be review. That's nothing new. We've done problems like that before. You guys have any questions on that one? Okay. Then for problem number 3, it is an equation that has a radical. So we've done radical equations before. Your goal for number 3 is to get the radical by itself first, and then you're going to square both sides, right? So you had one just like that on your final yesterday also. So what'd you guys do first? subtract the 1. Okay. And we have square root of 2x minus 2 equals x minus 1. So at this point, this is where we square both sides, and this is where some people kind of made a mistake yesterday as far as squaring the right side of this one. Squaring a square root just gets rid of the radical. So this side is the easy side, in my opinion. It's the x minus 1 squared that sometimes causes people to mess up. If you have x minus 1 squared, you don't just square the two individual terms. You have to either do a rectangle or you just distribute. Because x minus 1 times itself would be x minus 1 times x minus 1. Okay, so you have to work it out somewhere, whether it's by using this rectangle or just doing distributive property. Okay, x times x. X squared. And then x times negative 1. Negative 1x. Negative 1 times x is negative 1x, and negative 1 times negative 1 is 1. So on the right-hand side of the equation, we would have x squared minus 2x plus 1. That's what we get from there. And because of the quadratic, what are we going to have to do? Yep, we've got to get it equal to 0, which means these two need to go, right? So I'm going to subtract 2x, and I'm going to add 2. Subtract 2x and add 2. So that way this side equals 0, and we're left with x squared minus 4x plus 3. And then now that we have a quadratic, how do we solve it? We're going to do the asterisk. So I'd have a positive 3 with a negative 4, and both of these are 1x's. What are my two factors? Negative 3 and negative 1. So factored form would be x minus 3 times x minus 1. And once you have factored form like I have right there in the middle, most of you can just go straight to your two answers. What are my two answers? X equals 3 and x equals 1. Now at this point, you are supposed to check for extraneous solutions, right? You're supposed to plug them both in and see if they both work for the original equation. Oops. And if you plug them in up here, if you plug in a 3 first, you'd have the square root of 4, which is 2, and 2 plus 1 does give you 3. So plugging in the 3 works just fine. If you plug in the positive 1, you'd have the square root of 0, which is 0, plus 1, which does equal 1. So both of those answers actually turn out to be true. Okay? You guys good with that one? Okay. Problem number 4. They always have absolute value on the Ivy Tech final, which we do teach in Algebra 2, but for some reason it's not on the Algebra 2 final, which kind of blows my mind. But we are going to review how to do these, and since it has been a while for absolute value, keep in mind that anytime you guys have absolute value, it's very similar to the radical equation as far as you have to isolate those bars before you can do anything else. Okay, so like right now when I look at this problem, I see a minus 4 I'm going to have to get rid of, and I have the times negative 3 out front that I'm going to also have to get rid of, okay, before you do anything else. So which of those two steps would we have to do first? Yes. First step, we're going to add 4 to both sides. Okay, so we have negative 3 times the absolute value of 4a minus 1 equals negative 9. Then what? Divide by the negative 3 that's out front. And we have the absolute value of 4a minus 1 equals positive 3. And now do you remember what to do once those bars are isolated?
No, I forgot.
Did you stop there?
Yeah.
Okay, so this, think about if you could not see this, what numbers would have an absolute value of 3? Like what numbers on your number line are 3 away from 0? This is not a trick question, I promise. Positive 3 and negative 3. So absolute value, you always separate it into two equations. The first equation would be just 4a minus 1 equals positive 3. And then the other equation is 4a minus 1 equals negative 3. Now, in everyone's defense, we took the quiz that had absolute value problems on it day 3 of the term. Okay, and now we're like on day 30 or something. Today's either 29 or 30, I can't remember. But because of the fact that it's been so long, that's probably why some of you forgot. But yeah, anytime you have absolute value, you're always going to get two answers. A lot of times we do end up getting fractions, and that's okay. You can get a fraction or a decimal. Sometimes both of them end up being whole, but every once in a while you'll get either one decimal or two decimals. Okay, so I'm actually going to rewrite these over here because I'm completely out of room there. But you want to make sure you separate them. So I would add 1, and I'd have 4a equals 4, which means a is what? 1. Okay, so there's our first answer. And then if you add 1 over here, we get 4a equals negative 2. And what's negative 2 divided by 4?
No, wait.
Well, you'd have to reduce it. Negative 1/2. Yeah, it's negative 2/4, but we would reduce it to negative 1/2. And just like with everything else, you are supposed to take those two answers and plug them back into the original to see if they would give you true statements, and both of these do. If you were to plug both of those answers in, multiply it by negative 3, and then subtract 4 from it, you should get negative 13 both times. But just as a reminder to you, whenever you guys get two answers, especially in any kind of equation, sometimes one of them can be false. So you should always try to plug them back in and make sure that they're giving you true statements. Okay, so the entire first page has been done. And then last week when I went through the starred problems, we had already done 5, 6, and 7. So on the back of page 1, we just need to review number 8. You were supposed to watch the video. Yeah. Yeah, because you don't have to take your IB Tech final today. It's Monday, if you'd rather. That's fine.
Because I want you to help me. I just can't get it the same way when I watch the video.
That's fine. Okay, so problem number 8. Here we go. Again, you had a problem just like this on your final yesterday. If it says to find the zeros, they're wanting you to solve for x. So what kind of factoring would I do on number 8? Grouping. Yep. So we're going to group those two and these two. So I would have 0 equals, and then what does the first set of parentheses have in common? X squared. And that would leave 3x plus 4 in the parentheses. And then your second set of parentheses, if there's a minus sign, you want to put minus, and both of those are divisible by 3. And that also would leave 3x plus 4 in the parentheses. Then to write your two sets of parentheses, you group together the common factors. So x squared minus 3. And then the one they had in common is your other set of parentheses. And just like any other time we factor, as soon as it's in factored form, you separate them and you set them each equal to 0. So I'd have x squared minus 3 equals 0. Notice that says x squared. So at the end, when you take the square root, you'll need to put the plus or minus symbol. Yep. And then 3x plus 4 equals 0. That one's going to be a fraction. Okay, so I'm going to start with that one. Subtract 4. 3x equals negative 4. And if you divide by 3, I always leave mine in fraction form, so I left mine as x equals negative 4/3. You could turn that into negative 1.3 repeating. Okay? And then this one over here, if I add 3, I'd have x squared equals 3, and then that's where you would take the square root. So do you guys know the square root of 3? No. So that's, you just leave it the square root of 3. You just want to make sure you put plus or minus in front of it. Okay? So there's 2 of our zeros, and there's the other 0. Those are your answers. You guys feel okay with problem number 8, grouping? Okay, I had done problem number 9 already, so we're going to do 10, 11, and 12 on the next page. Number 10 are those vertical, horizontal. When it says slant asymptote, that is the same thing as oblique. And I feel like the day that I went over the starred problems, I told you on number 10 that the only time that there is a slant asymptote or oblique is when the degree up top is bigger than the degree on the bottom. And on this case, it's not. So we don't have to worry about slant asymptotes. I told you guys just for slant, you can write no slant asymptote. But everybody is expected on number 10, just like you'll be expected to on your Ivy Tech final, to find the vertical and horizontal. And we did a whole lesson on that last week also. So how do we do the vertical asymptotes?
I forget. Is this the one where it has the, like the... Oh, the vertical one's on the bottom, right?
The vertical is just your denominator set equal to 0.
Okay.
You're talking about horizontal. Okay, so we'll get there. So let's start with the vertical asymptotes. So I always just put like VA, and we'll show the work there. Okay? Your vertical asymptote is found by setting your denominator. So the x squared plus 8x minus 33 equal to 0, which means we have to do an asterisk, right? Because we're going to get 2 answers for this one. So it'd have negative 3 and positive 8. Did I say 3? I meant 33, I'm sorry. Negative 33 and positive 8. So what are my 2 factors? Okay, and which one's the negative?
3.
The 3. So here are my 2 sets of parentheses. This is factored form, x minus 3 and x plus 11. And once it's in factored form, then you should be able to go ahead and tell me the 2 x's. So x equals what and what? So x equals 3 and x equals negative 11. So there are your 2 vertical asymptotes. Excuse me. And again, those are vertical asymptotes because those 2 numbers, if I were to plug a 3 into my denominator right now, the denominator would be 0. And you're never allowed to have a 0 on the bottom. So that's one of our breaks in the graph, is at that x equals 3. The other break would be at the negative 11. So if you were to plug in a negative 11 in the denominator spot right now, you'd get a 0 on the bottom, and that's not allowed. Okay? Now, horizontal is when you compare the degrees. The exponents, yep. The highest exponent for each one. So the horizontal asymptote, you always write y equals. No. When the top is smaller than the bottom, that's when it's y equals 0. But if they're the same, you just write their leading coefficients. So what's the number up top? -3?
Yeah, negative.
And then on the bottom, it's a 1, so it's just y equals -3. Yep. Good. Okay. Problem number 11 is composite, and you guys had composite functions on your final yesterday. Composite is when you take one function and you plug it into the other. So on number 11, which one do I have to plug in? You have to plug in G into F, right? Because G is the one on the inside. So this is going to take quite a bit of work, actually, because normally you guys are used to just plugging in where there's just one X. Well, now there's actually two different places that we're going to have to plug it into. Let me scroll up so I have plenty of room here. And then not only do you have two places to plug it into, but doesn't one of them have to be squared? So that's going to take some time too. Okay, so I'm taking 4x minus 5. I'm going to put it there and there. So we'd start with 4, and then I would go ahead and insert the 4x minus 5. That's the one that has to be squared. Then you have plus 4, and now I'm going to insert the 4x minus 5 again, and then plus 3. So we now have to simplify this thing. You can't just leave it and move on. This right here is going to be easy because we're just going to distribute. But before we do any kind of distributing, we've got to simplify the 4x minus 5 to the second power. How do we do that? We can do a rectangle, or you'd have to write out a distributing problem. But 4x minus 5 squared is 4x minus 5 times itself. So I'm going to do that over here. That's just an extra problem within this problem that we need to do. And what's 4x times 4x? 16x squared. Then we'd have 4x times negative 5. And then we have 4x times negative 5 again, which is negative 20x. And negative 5 times negative 5. Positive 25. Okay? So, when I go to rewrite this, the 4 is still out front, but now inside parentheses I have all that stuff that I just wrote in red, and I'm going to go ahead and combine my middle terms. So I'd have 16x squared minus 40x plus 25. And then everything else is going to come down, right? I could go ahead and distribute these. What's 4 times 4x? 16x. What's 4 times negative 5? Negative 20. And then you still have the plus 3. So I simplified what I had highlighted, right? That's how I got this. And then I also distributed here to get this 16x minus 20. Okay, so I kind of did two things at once, but don't I still have to distribute the 4 now? I still have to do this. I have to multiply all three of those terms by 4. So 4 times 16, we have 64x squared. And then I need 4 times a negative 40x. Which would be negative 160x. Is that right? Okay. And then 4 times 25. is
Or
100.
I hit 5 instead of
It's
4.
okay. It's 100. And then everything else that's up here, we can just bring down, because then the last thing we're going to have to do is we're going to have to just go through and combine all of our like terms, right? And then we'll be done.
Oh, we won't have to like.
They didn't give us a number up here to plug in. The one on your final yesterday, they gave you a number to plug in at the end. But this one, since it just has X up there, you're just leaving it in terms of X.
I was getting worried with the X squared that we were going to have to
Nope.
at the end of the last year's.
Nope. We are just simplifying. So the 64x squared is by itself. But when you guys combine your two x terms, these two, what do you get? Negative how much? 144x. And then you've got three constants to put together. You've got 100, a negative 20, and a positive 3. 83. And finally, that is as far as we need to go. So when it says find the composite, it's a big plug and chug problem. But then once you plug that in and do your substitution, everything beyond that was just all simplifying. A whole bunch of multiplication, and then eventually you're just combining like terms. So are we good with number 11? I mean, a lot of work, but nothing that you guys can't handle. Especially, if you're a dual credit student, we should definitely be able to handle, doing all that multiplication and combining like terms. Number 12, I corrected it at least on mine here. Hopefully the other schools did as well. But on number 12, I had accidentally put in an equal sign between the x and the 2, I think. But I fixed it, didn't I? Oh, I fixed it probably on Jessica's because she was here that day and you weren't. So
I was looking at that like that.
yeah, sorry. So if everybody at all the schools looks up at the screen right now, it's supposed to say f of x equals x plus 2 to the third minus 8. Okay, so yeah, that was a typo. That was me forgetting to hit the shift on my keyboard when I typed it up. Okay, so how do we find inverses? Because there was one just like this on your final yesterday. We start with y equals, and then we have x plus 2 to the third minus 8. Trade places of the x and the y. And now get y by itself. So what do I do? Add 8. So we have x plus 8 equals y plus 2 to the third. And if you have something to the power, we cancel it out by making the radical, right? But we're not taking the square root. What root are we taking? The third root. And we don't know what the third root of x plus 8 is, so we just leave that as the cubed root of x plus 8. But on the right side, the power and the root cancel each other out, so you just have that y plus 2. And then you've got one more step. Subtract 2. And that 2 cannot pair up with the 8, because the 8 is under the radical, the 2 is not. So my final answer, I go back to inverse notation. So f of x, but you put that negative 1 as the exponent. This was really sloppy, sorry. There we go. Equals cubed root of x plus 8. And then the minus 2 is just at the end. And it is not supposed to be under the radical, so make sure I can tell that it's after the radical. That's the final answer. Any questions? So you really don't have that many more to go. 13 through 15 on the next page. And then the last page, those are all really pretty fast problems, those last 4. Is everybody okay so far? Okay, then number 13 says simplify the expression in the form a plus bi. So distribute first. Watch where you get your I squareds. Okay? So if we multiply this out, what would you get there? 6 plus 10i. Okay? Then we want to distribute 4i. So 4i times 5 is 20i. And then it's just, what's going to happen when you take 4i times negative 2i? It would start out as negative 8i squared, which we will eventually turn into, I'm just going to go ahead and write it separately, but you could have changed it there. What does that become? Positive 8. Yep. And now just combine your like terms. They do want you to put a first. It says that specifically. So what is 6 plus 8? Those two together would make 14. And then the 2i terms together, 30i. And that is final. 14 plus 30i. That one's actually not too bad. Really what they're testing you on there is probably that I squared, just making sure that you remember how to simplify the negative 8i squared, making it positive 8, and then just combining like terms. Good? Okay? When I look at 14, I see a proportion, and anytime I see proportions, I cross multiply. The only thing is right now I do see a squared, and when I see a squared, I start thinking, oh, I'm probably going to have to do an asterisk at some point in this problem, right? Because it's going to be a quadratic when we multiply. So let's see what happens. If you have not already started this problem, go ahead and cross multiply and tell me how we would do our multiplication here. Okay, so 4 times m squared minus 9 equals, and then what would go on the other side? 7 times m minus 3. Okay, now some of you might have skipped that step and you may have just distributed first as you went, and that's fine. I just typically show that anyway. So now I am going to go ahead and distribute. So I have 4m squared minus 36 equals 7m minus 21. Okay? So even if you skipped this first step, everybody should at least have the 4m squared minus 36 equals 7m minus 21. And whenever, like I said before, if I see a squared, I'm going to move everything to one side. So I would subtract 7m and add 21. Four m squared is by itself. The negative 7m has nothing to pair with, but it has to go in the middle. And then what's negative 36 plus 21? Negative 15 equals 0. So at that point, you have two options. If you don't want to bother with the asterisk, then you could do quadratic formula. Quadratic formula will always work. I just like to do the asterisk if I can. So I tried it. And 4 times negative 15 is negative 60 would go up top. I'd have a negative 7 here, and I had 4m on each side. So are there two numbers that multiply to make negative 60 that add to make negative 7? Negative 12 and positive 5. Now, one set of those parentheses will reduce and one won't. So like the 4m plus 5, that's not going to reduce. But what can the 4m minus 12 become? 1m minus what? Yep. Minus 3. That can become 1m minus 3 because they're both divisible by 4. And then you just have to solve each one of those separately. So we'd have 4m plus 5 equals 0. And I'd subtract 5. 4m equals negative 5, which means m is, I put negative 5/4 because I like to leave mine as a fraction. It is negative 1.25. And then the m minus 3 would give me m equals 3. Okay, quick question. Do both of those answers work for the way the original problem was written? Because aren't they both fractions the way they're written? And if I were to plug in that number 3, what is my denominator going to be? If I plugged in a 3 here and here, wouldn't both of those denominators be 0? Are you ever allowed to have 0 as a denominator? No. So this 3 is actually not a solution. It would be extraneous. So even though it worked for the quadratic, it did not work for the original problem. Negative 5/4 would be fine because negative 5/4 minus 3 is not going to give me 0. Okay? So always check for that at the end. If neither one of them would have made it a 0, they both would have been fine. It's just because that 3 made it a 0. All right, how do you feel about 14? Pretty good? It's proportion, quadratic, asterisk. Okay, now 15 does not say anything about direct variation or anything like that, but whenever I read some kind of story problem, if they're comparing two things, like on this one it says the property tax on a house that is $150,000, the property tax is $900. Okay, then it says at this rate, what is the property tax on a house that's $200,000? Well, if they say that the rate's exactly the same, can't we just set it up as a proportion, comparing the value of the house to its property tax? Yeah. So this is just nothing more than a proportion problem. So how do you guys want to set it up? It doesn't matter which one we put on top. Just pick one and go with it. Okay, so if you started with the property tax, we would do the tax, which is 900 over 150,000 equals, so then where's the 200,000 go, top or bottom? Goes on the bottom. Now for people at other schools, if you guys had set it up as 150 on top, then you'd make sure you'd put the 200 up top also. And then we don't know the property tax for this house. So you just came up with your proportion, cross multiply and divide, and you guys will have your answer. $150,000x equals something really big. 1, 2, 3, 4, 5, 6, 7 zeros. 180 million. Is that right? Did I put too many zeros?
No, 7 zeros.
Okay. So if you take that and you divide by 150,000, what do we get? 1,200? And it's talking tax, so I mean obviously put a dollar sign on that and that problem's done. Okay, we had done problem 16. So then now on the last page, 17 through 20, 17, they're just asking you for vertex. So if the quadratic has been given to you in vertex form, you guys just have to figure out, do those two numbers, the one that's in parentheses and the one that's on the outside of parentheses, do they both stay the same? Do they both change? Or does one stay and one change? And that's something we've talked about so many times. Which one stays? Which one changes? What's the vertex? The one on the inside always becomes the opposite. So the x coordinate always becomes its opposite. So that'll turn into a positive 3, and then the positive 5 stays the same. You had a problem like that on your final. It was multiple choice. I think on your Ivy Tech final it's also multiple choice, but I didn't make any of these multiple choice, but you do have some on your Ivy Tech final that are multiple choice. Okay? Still done the same way though. 18 is function operations, and they're just telling you to subtract the two. So what I did, if they want me to subtract f and g, I started with f and I wrote negative 5x. Then I put a minus sign, and then they want me to subtract g, so I wrote this, the absolute value of x minus 3. And they want you to do what with the 4? Just plug it in. So plug it in wherever you see an x. So I did negative 5 times 4 minus the absolute value of 4 minus. And then you guys would just simplify that. So what is negative 5 times 4? Negative 20 minus, and we can do this in our head. What's 4 minus 3? 1, and what's the absolute value of 1? 1. So we're doing negative 20 minus 1 is negative 21. There's your answer. So I just said that 4 minus 3 is 1, and the absolute value of 1 is also 1. So we did both of those things at the same time. What? Whatever. This right here was the absolute value of 1. So I said negative 20 minus the absolute value of 1. And then went over here. $19 is going from log form to exponential form. So all you have to do on 19, which there was one of these on your final yesterday, identify the base, identify the exponent, and just write it as a base raised to an exponent. So which one's my base? The 4, the exponent equals 64. Real simple problem. 4 to the 3rd equals 64. And then final problem, you've got a log equation. There's one log per side, so it does not get any easier than this. If it's one log per side and they both have the same base, how do we solve it?
Set the parentheses equal.
You just set the two expressions equal to one another. Yep, so 4x minus 3 equals x plus 9. And then get x's to one side, so I subtracted a 1x. I have 3x minus 3 equals 9. Then what? Add 3. So 3x equals 12. And x is equal to 4. Now the only thing you have to be careful on is, remember, you don't want those in there to be zeros or negative. But if I plug in a 4, both of them would be fine. Okay, so we're good with that problem. And that is the final problem on your practice final. And the way it was set up is just like how your Ivy Tech final is set up. Okay, so there is no hurry for people to take their Ivy Tech final today. I scheduled it for next Monday. If you feel confident and you want to start it today and your facilitator has them run off, you can. If not, just spend between now and Monday reviewing for your Ivy Tech final, and then you guys will all be finished after you take your Ivy Tech final. Okay?
How many can you miss?